Well, what you can see on your screen right now may seem as just some numbers written down without any meaning. So let's attach some meaning to it. Suppose we say that 45 people, so this represents the number of people working for 12 hours a day can actually do some work which is equivalent to 500 units in 25 days. So I repeat, 45 people working 12 hours a day complete 500 units of work in 25 days. The question now is, if instead of 45 people we have 30 people who are going to work for 15 hours a day and they have to produce 300 units of work, then how many days would be required? If you want to solve such a problem, then we need to go through some concepts of ratios and variation, and once we do that, this problem can be solved in absolutely no time. So let's move on to some concepts of ratios and variation. Let's understand what is a ratio. Suppose we say that a vessel contains 24 liters of milk and 60 liters of water. And if we want to differentiate between a term called as ratio and another term called as a fraction. So we've said that a vessel contains 24 liters of milk and a vessel contains 60 liters of water. And now if I want to write a ratio, then I would say that milk is to water would be 24 is to 60, which is nothing but 2 is to 5. So as a ratio, I would say milk and water in this vessel will be in the ratio 2 is to 5. But now if I want to understand in terms of a fraction, I know that in this vessel, 2 parts out of a total of 7 parts is milk and 5 parts out of the total of 7 parts is water, and hence as a fraction I would say milk is 2/7 of the vessel, whereas water is 5/7 of the vessel. So when we talk in terms of a ratio, it is simply how much milk is to how much water, but when we talk in terms of a fraction, we say how much milk out of the total and how much water out of the total. If we get these two concepts clear, then calculating using a ratio, when a ratio is given, and how to convert it into a fraction to find the necessary values becomes very, very simple if this is very clear in our minds. Let's look at a few properties of ratios. We're going to go through 5 properties. Let's go through them in order, one after the other. So let's take the first one. If we are given A upon B is equal to C upon D is equal to E upon F, 3 ratios are given as equal, then each ratio would be equal to the sum of all the numerators divided by the sum of all the denominators. This is commonly referred to as property of equal ratios, and this need not be restricted to 3 ratios. You may have any number of ratios as equal, then each ratio would be equal to sum of all the numerators upon sum of all the denominators. Let's look at the second one. If it's given that A upon B is equal to C upon D, then we have A plus B upon A minus B is equal to C plus D upon C minus D. If you notice, what we've done is we've just taken the sum of the numerator and the denominator divided by the difference of the numerator and the denominator on each side, and they would be equal. This property is commonly known as componendo dividendo and is extremely useful in problems. Let's look at the third one. We now have 3 ratios where it's given A upon 7 is equal to B upon 5 is equal to C upon 4. And what we need to do is we just need to write down the ratio for A is to B is to C. Then it simply becomes 7 is to 5 is to 4. Whatever was there in the denominators can be, if I take this as equal to K, then each one would become, A would become equal to 7K, B would be equal to 5K, C would be equal to 4K, and hence when I take it as a ratio, K would get cancelled, and that's what we get. Now instead of a upon 7 we have 7a. This actually can be given or stated in a question as 7 times A's amount is equal to 5 times B's amount is equal to 4 times C's amount. And if the total value for A, B, C put together is given, and if the question asked is how much does A have or how much does B have or so on, then we would start with this, and our next step would be hence A is to B is to C, which would be equal to 1 upon 7 is to 1 upon 5 is to 1 upon 4. That would be our first step. And now if you want to convert that into simple numbers and not fractions, what we would do is take the LCM of 7, 5 and 4 and multiply each fraction by that LCM, and hence this would get simplified as 20 is to 28 is to 35. So that would be the final answer. Now there's another way of directly arriving at this particular answer. When I go back to this, and if I want to write a value corresponding to A, then I just cover 7a, I look at the other two and multiply the two numbers that I can see, and that would be the value equivalent to A. If I want to write the value corresponding to B, I cover this part of B and multiply these two numbers 7 and 4, that becomes the value corresponding to B. And similarly for C, if I cover this, then 7 into 5, which is 35, becomes the value corresponding to C. Now when you use this method, it is possible that the ratio that you obtain here may not be in the least possible form. There may be something common which you can just cancel off and hence express it in terms of the least possible form. Finally, let's look at this kind of an example where you have A is to B is 3 is to 5 and B is to C is 4 is to 9, and the question asked is how much is A is to B is to C. Now if you want to combine these two ratios, then we need to first check what is common in the two ratios, which here is B, and look at the value equivalent for B. So here the value equivalent is 5 and here it is 4. What we would do is we would convert the value corresponding to B into the same value in both these ratios, and that we would do by taking the LCM of 5 and 4, which is 20. So we would write A is to B as, if 5 is converted into 20, which means multiplied by 4, 3 would be converted to 12. So this would be 12 is to 20. Similarly, this would be 20 is to 45. And now that the value for B becomes the same in the two ratios, we can straight away combine it as 12 is to 20 is to 45. So the trick here is find out which particular variable is common. The value corresponding to that variable should be converted to the same number, and then simply combine the three numbers to get one single ratio for A is to B is to C. What do we mean by proportion? So if we are told that 4 terms A, B, C and D are in proportion, which is very commonly stated as this, then it simply means that A upon B is equal to C upon D. So in other words, if in a problem you are told that A upon B is equal to C upon D, then it means that A, B, C, D are in proportion. Now what is the implication of this? If we cross multiply, we would get A into D is equal to B into C. And this is very commonly referred to as product of the means is equal to product of the extremes. So what that means is when we take 4 terms in proportion, the two end terms are referred to as the extremes and the two middle terms are referred to as the means, and hence we say product of the means is equal to product of the extremes. Now a variation of proportion could be an example of continued proportion. So if we say A, B, C are in continued proportion, then it would simply mean that A upon B is equal to B upon C. Since B gets continued, it's referred to as continued proportion. And hence if again we cross multiply, we would get B square is equal to AC. In continued proportion, B is referred to as the mean proportional, or it can also be called as the geometric mean of A and C. So this is what is the meaning of proportion, which would mean A upon B equal to C upon D, and a variation of that for continued proportion would simply mean A upon B is equal to B upon C. Having seen ratios and proportion, let's now move on to a third concept called as variation. Now what do we mean by variation? There are two kinds of variation that we would look at, something called as direct variation and something else called as inverse variation. So if we say A varies directly as B, which is stated as A varies directly as B in this manner, if there is direct variation, then what that means is if A increases, then it implies that B would also increase. Hence, direct variation. An increase in A would automatically cause an increase in B. A decrease in A would cause a decrease in B. Now, if we have to solve this, then we can also say A is equal to K into B, where K is nothing but the constant of proportionality. Now, if A is equal to K into B, and if I take a specific value of A1, for that specific value A1, I would get a specific value B1. So I can say A1 is equal to K into B1, and similarly A2 is equal to K into B2. Now if I divide these two, I would get A1 upon A2 is equal to B1 upon B2, because K being constant would get cancelled out. So any problem of variation, for example in direct variation, if we say A varies directly as B, then in a problem you can directly move on to this step, avoiding the constant completely, and hence out of these four terms, if any three are given, the fourth can be calculated. A slight variation of this kind of an example could be if A varies directly as B and C. Then we would state, instead of A varies only as B, we would say A varies as B multiplied by C, and then from there if I jump to this particular point, I would say A1 upon A2 is equal to B1 upon B2 multiplied by C1 upon C2. So if I have multiplied this by C, I would multiply this by C1 upon C2. So what this now tells us, out of these 6 terms, if 5 are given, the 6th can be calculated. Now this is direct variation. Inverse variation would be stated as, if A varies inversely as B, it means A is proportional to 1 upon B. Now if I use this logic, or if I go back to this point, when A increases, B will decrease, and when A decreases, B will increase. Hence inverse variation. Moving on to such a point, I had straight away jumped from A varies as B into C, because it was direct, as A1 upon A2 equal to B1 upon B2 into C1 upon C2. So now if it is inverse variation, we can straight away say A1 upon A2 is equal to B2 upon B1, because this is inverse variation. So once again, whether it is a question of direct variation or inverse variation, questions can directly be solved without calculating the constant of proportionality, because calculating this would only mean one additional calculation to be done, which is not really required. So now that we've gone through the concepts of ratios and variation, let's go back to the example that we had started off with. We had looked at this example where we said 45 people working 12 hours a day can complete 500 units of work in 25 days. So if now we have 30 people working 15 hours a day, and if they are supposed to complete 300 units of work, how many days are required? We're going to make use of the concepts of variation out here, and we're going to solve this problem using what is commonly known as the chain rule. Question asked is the number of days. So obviously the number of days that we need to find out would be related to the previous number of days that we have, and hence let's start with the number 25 and see how to move beyond that. We're going to relate each parameter with the number of days. So if we now look at the number of people, earlier it was 45 and now it is 30. So we can say that the number of people has become 2/3 of what it was earlier. And since people would be inversely proportional to the number of days, what do we mean by that? Since the number of people goes down, the number of days required would go up, and if the number of people has become 2/3 of earlier, then the number of days would become 3/2 of earlier, and hence we multiply the earlier number of days by 3/2. We've accounted for the number of people. Let's look at the number of hours. If we look at these two values, we can say that the number of hours actually changes from 12 to 15, which means if I take this as 4 and this as 5, then the number of hours has become 5/4 of the earlier value. Once again, number of hours would be inversely proportional with respect to number of days, which means if number of hours increases per day, number of days required would be lesser. Hence, if the number of hours has become 5/4 of earlier, then the effect here would be that the number of days required will become 4/5 of earlier. So we are multiplying further by 4/5. Let's now take the third parameter, which is the number of units of work to be done. The number of units becomes 3/5 of earlier. Since the number of units or work to be performed goes down, number of days required would also go down. So there is a direct variation, and since the number of units to be done becomes 3/5 of earlier, the number of days required would also become 3/5, and hence now if we solve this, we would actually find the answer to how many days are required. And what we can simply do here is 25 cancels off, and hence the number of days required would be 18 days. So this is how we can solve a question of this type using the concepts of ratios and variation. So looking at whether there is a direct variation or an inverse variation, and accordingly calculating the value of the question asked.